dear students, welcome back. In this video we are going to discuss about the non-exact differential equation with the case number 3 and 4. So let us proceed with the case number 3. Suppose that the equation number 1 is non-exact, and if it is of the form dx multiple of the y and dy is a multiple of x, that means in general form f1 of xy y dx plus f2 xy into x dy equal to 0. If it is of the form, then we will proceed with this integrating factor. So 1 divided by mx minus ny. It is not the partial derivative. Where m is what? This is our m. And m2 is what? This is our n. Sorry. This is m and this is n. If it is integrating factor is there, provided mx minus ny should be non-zero, because of the denominator quantity, it should be the non-zero. So integrating factor multiply with the equation number 2 and we will get this one, and this will be the m star and this will be the n star, and this will be the exact that you can verify. And after that, as usual, general solution is that integration m star of xy over the y constant dx plus integration of n star y over the x free dy is equal c. That is the integrating constant. That will be the general solution. So let us move on to the particular question. So it will be the very clear which kind of the case we are going to proceed with. Suppose this is the equation x square plus y square plus 2 times, and here it is mentioned that multiple of this bracket with y dx plus 2 minus x square y square into x dy is equal 0. So this is the equation number 1. So first let us do the first comparison with the standard form m dx plus n dy is equal 0, and you will get this is the m and this is the n after multiplying y inside, so you will get this m and this is n. Now let us find del m by del y, and this is the del n by del x. But question is that, can we apply case number 1? So for that, I'm just going to start with the del m by del y minus del n by del x. Let me check it, is it feasible or not? So here what I'm just going to get, if I take the subtraction of this one, so this is the 3 times x square y square plus 2 plus, this is the plus but minus is there, so this is the minus 2 times and plus 3 times x square y square. So this is going to be cancelled out, so we will have 6 times x square y square. Now what I'm just going to consider, this I multiply by 1 by n. So n is what this is, and this function is not going to be held to have the one variable function, whether f of x or g of y. If I replace m by n, then also it is not going to be held. That means this case is not applicable. Then what? Look at the case number 3, that dx has a multiple of y and dy as a multiple of x. Then we proceed with the case number 3, and in that case first we find the mx minus ny. So this is our mx minus ny, so answer is going to be 2 times x raised to cube into y raised to cube, and then integrating factor is 1 divided by mx minus ny, so you will get this one, our integrating factor. Now let us move on to the proceed with integrating factor multiply with the equation number 1, and after simplifying you will get this is our m star and this is going to be n star. Now let us do that the del m star by del y, keeping x constant, so this is going to be 0. And what about here? So in that case minus 2 times x raised to cube divided by y raised to cube, because we know that if f of x is equal 1 by x, so and its derivative is going to be minus 1 by x square, and in that case sub double derivative will be what? That also you can find that minus, if this can be written as x raised to minus 2, and minus 2 is there, so x raised to minus 3. So after simplifying, 2 divided by x raised to cube, and hence it is written over here, this is minus 2 times x raised to cube y raised to cube. Now del n star by del x, so keeping y constant, so this is y raised to cube is going to be constant, and 1 divided by x square is there. according to this one. So our answer will be 2 divided by x raised to cube, and therefore we have written over here, but minus is there. So we can conclude that both the answer del m star by del y is equal to del m star by del x, and this is equal, and therefore it is going to be equation number 3 is exact. So therefore its general solution. So let us write its formula. So this is the m star dx over y constant, and this is the n star of y over the x free dy is equal C. So let us put here first m star. So here you can see that the m star already have written over here, and this is the n star, and n star is what? N star y. This is the function contain x, so it is not going to be there. So we are going to focus only this one. So minus 1 divided by 2y dy is equal C. Now just do the integration with respect to x, that also you can do. And also this is the ln x and ln y, but 1 by 2 is that, just I have taken 2 LCM and multiply on the right hand side, and 2 c dash. 2 c dash will be what? Exactly only c. So I have written new constant, that is c. So ln x by y is there because we have the result that ln a minus ln b can be written as ln a divided by b, and this can be written, and this is what exactly general solution. So now the last case, if m dx plus n dy is equal 0 is a homogeneous equation in x and y, then our integrating factor will be 1 divided by mx plus ny. Just keep in mind that if it is homogeneous, then also you can go through with this. But first our mind makes that, is it first exact or not? So let us check that del m by del y and del n by del x, it will be the different. Then we just go through the case number 4 of the non-exact case. So then after we follow the same integrating factor, multiply with the equation number 1, and this is the general solution. So let us see the example number 2. And it is written that solve x raised to 4 plus y raised to 4 dx minus x times y cube dy is equal 0. So this is clear that both are the different from that for the non-exact. Since the equation number 1 is nothing but homogeneous, but question says that can we apply the case number 3? Answer is no. Why not case number 3? Is it of the form f1 xy y dx plus f2 xy x dy is equal 0? Answer is no, this is not the form, and therefore case number 3 is not applicable. Can we apply case number 1 or 2? Let us check. Del m by del y minus del n by del x. So what you are going to get? Subtraction of this. It will be 5 times y raised to 3, that you can see. Then I have to multiply with 1 by n. N is nothing but minus x times y raised to cube. So it is clear that minus 5 by x is there, and this is the only one variable function. That means we can consider integrating factor is equal e raised to integration f of x dx, and you can proceed with this. So this is our method number 2, and this is what exactly our method number 1. That means case number 2 is also applicable. I hope that it is clear to all of you that which case we can apply and which case we cannot apply. Just try to check in your way, so it will be very easy to understand. So let us see here. I am just going with the homogeneous differential equation. So for integrating factor, also you can assume 1 divided by mx plus ny. 1 divided by mx plus ny, that it is clear that multiply with x, multiply with y, and you will get this one, and after simplifying 1 divided by x raised to 5 is there. Now our target is what? To multiply with the equation number 1. So I'm just going to multiply with this, and after simplifying I will get this is m star and this is n star, and then we will find the term del m star by del y and del n star by del x, and you can verify that both are both equal, therefore we can say the equation number 2 is going to be exact, and therefore general solution is given by here. Yes, right, this is m star and n star y, so it is clear that this is not free from x, it contains x, therefore n star y is equal 0. Now just do the integration with respect to x, so ln x minus y raised to 4 divided by 4 times x raised to 4 and equal to c, that you can do integration, so I'm not going to discuss here that how we obtain that integration with respect to x, and this is what required general solution. So let us solve example number 3. Solve xy minus 2y square dx minus into x square minus 3xy dy is equal 0. So this is our equation number 1. This is our m and this is our n. After multiplying minus inside, now del m by del y, so it will be here, this is x minus 4y del n by del x, so it will be the minus 2x plus 3y. So clearly these are the different from del m by del y is different from del n by del x. So therefore the equation number 1 is not exact. If it is not exact, then that means we can make this equation number 1 into exact, but we need to find out the integrating factor. So we have discussed all the case number 1, case number 2, case number 3 and case number 4. So we can summarize that if the differential equation is look like that the homogeneous, so just consider the case number 4. This is the differential equation with the homogeneous degree, that means same degree, that is the degree contains here 2, 2, again 2, 2, so both are the same. Therefore, the equation number 1 is homogeneous form, homogeneous differential equation, and therefore our integrating factor is equal 1 divided by mx plus ny. So let us find first mx plus ny. Just multiply with this x, so x square y minus 2 times xy square, then plus ny. If I multiply with y, so minus x square y plus 3xy square. So after simplifying, what you are just going to get, this is x square y, so it is going to be eliminated, and this is a minus 2 times, and this is a plus 3 times xy square, so it is clear that xy square there. Therefore our integrating factor will be 1 divided by xy square. So our equation number 1 multiply with the integrating factor, so we will get that xy minus 2y square multiply with the integrating factor, so xy square is there, and this is the dx, minus x square minus 3xy multiply with the integrating factor, so this is the xy square, dy is equal 0. So let us simplify this one, so xy will be the cancel out, so we will get that 1 divided by y minus 2 divided by x dx minus, if I divide by xy square, so x will be the cancel out, so I will get x divided by y square minus x also y is going to be cancel out, so I will get 3 divided by y dy equal to 0. So here this is clear that this is the m star and this is nothing but n star. So I write that m star is equal 1 by y minus 2 by x, and n star will be what? This is minus x divided by y square, but minus minus plus 3 divided by y. So let us find del m star by del y. So it is clear that minus 1 by y square is there. Del n star. So it del n star by del x. So what it will be minus 1 by y square, and this is going to be 0. That means the equation number, this one number say this is the 2. So we can say equation number 2 is exact. Why it is exact? But it is clear that both are the same. So let us proceed with general solution. So therefore general solution integration m star dx over y constant plus n star of y over x free dy is equal c. But here m star is what? 1 by y minus 2 by x dx plus here x is free and n star is what? That is we want only free from x, so this is going to be our n star of y. So I'm just writing that this is the minus 3 by y dy is equal c. So let us do the first integration with respect to x, keeping y constant. So here you can say this is x by y minus 2 by x is that. So what I can say 2 times ln x, and this is minus 3 times ln y is equal, that is c. That also you can write that this is the ln x square. If I make minus common, so I can mention that this is the ln y cube equal to c, and that also you can write that this is the ln x square y cube is equal c, and this is going to be what your final answer. I hope that it is clear to all of you. So in this video we have discussed about the non-exact case number 3 and 4. Thank you.